Today we are going to start with the 12th session of Boolean Algebra chapter. Whereas in the previous class we already explained what do you mean by min term, max term, their designation, how to find out min term values, max term values. With that, all the postulates in the previous class we explained. Today I want to explain regarding the canonical form. Canonical form, how to find out canonical form of an expression, how to calculate that, how to identify the designation. Regarding that, today I am going to explaining you. Whereas here, canonical form, what do you mean by this canonical form? Any Boolean expression can be expressed as sum of min term or product of max term. This can be represented in two methods. One is min term form, canonical min term, and one more is canonical max term. Today I am going to explain how to find out the canonical form of an expression. For example, consider you have an expression, how to find out their canonical form. That today I am going to explain. In the exam they will ask how to find out the canonical form, whereas canonical form is nothing but any Boolean expression can be expressed as sum of min term or product of max term. Is call it as canonical form. Now, whereas in the exam if they given conversion of SOP into canonical form. Consider that they given the heading convert SOP. SOP stands for sum of product form. Consider one expression x plus x bar y plus x bar z bar. Consider this is the equation you have x plus x bar y plus x bar z bar. First step itself, you have to find out which is the missing term on the given min term. Whereas on this part, we have only x, but y and z are missing. When you see the expression, totally three variables, x, y as well as z. But in first part, y and z are missing. In second part, only z is missing, whereas in the last part, only y is missing. Then, first you have to find out which are the missing variable. Here x is missing. Then what I can write? X into 1 I can write, because this one represents y and this one represents z. Because x into y plus y bar is nothing but 1 only. Once again, z plus z bar is also 1 only. See here? Z plus Z bar is also 1, Y plus Y bar is also 1. I can convert the given expression in such a way that x into 1 because two variables are missing. Here x bar y into 1 I am to write. Whereas in the last part x bar into 1 into Z bar. Now on this place x1 write on y plus y bar. For z also z plus z bar. Next write on the second part plus x bar y z plus z bar. Whichever variable is missing, that variable plus variable complement you have to take. Then plus x bar. Here y is missing, that's why y plus y bar into z bar. Now distribute the given equation. First I have to distribute x with the y. xy plus x y bar. Distribute these two parts, then z plus z bar. Then here also distribute the equation x bar y z plus x bar y z bar. Distribute the given equation. Next once again x bar y z bar plus x bar y bar z bar. Now here once again we have two parts. Once again distribute the given equation x, y, z. First I have to multiply with this one plus x, y bar, z. First I have to multiply z with the first part and then z with the second part. Next once again z bar with the first part, z bar with the second part plus x, y, z bar plus x, y bar, z bar. See the equation? First x, y and then z. Once again x, y bar, then z. Once again we'll take this x, z with first part and then second part. Next once again this z bar with first part as well as second part. X, y, z bar, x, y bar, z bar. Remaining thing write down as it is. X bar, y, z plus x bar, y, z bar plus x bar, y, z bar plus x bar, y bar, z bar. Now, in all the part we have all the three variables. First step, identify the missing variable, then combine that missing variable plus missing variable complement, then distribute the given equation. Later on, remove all the duplicates. See here, how to remove all the duplicates? X, y, z. Just see the expression, is anywhere x, y, z? No, only one time we have, that's why I'm to write x, y, z. Next, write down, only for y we have bar. See the expression, only for y we have any bar? No. Then this part will write x, y bar, z. Then next, see, only for z bar we have complement, z bar. See the expression, only for z bar, then we don't have any duplicate, x, y, z bar. Then see the equation, only for y bar and z bar, y bar and then z bar. No, then write down x, y bar, z bar. Then next, see, only for x there is a bar. We see the equation, there is no anything, that's why x bar, y, z. Plus once again, only for x bar and z bar here we have. See these two equations, these two part, these two are same format, duplicate we have, that's why we can write only one time. X bar, y, z bar plus x bar, y bar, z bar. First step, identify the missing variable plus missing variable complement, multiply that, then distribute the equation. After distributing, remove the duplicate. Then next, write down the min term designation. How to find out that? In min term, already we explained. In min term, if you have a variable x, then we used to write it as 1. If we have x bar, then we used to write it as 0 here. If it is complement, then we'll write 0. If the variable, if it is non-complement, then we used to write 1 there. Now in the same pattern, here we will write x, y, z. We don't have any complement, then write down 1, 1, 1. Plus, next write down x does not have any complement, that's why 1. But for y we have complement, then 0, then 1. Plus, for this one, x and y does not have any complement, that's why write down 1, 1. Only for z it is complement, that's why 0. Next, 1, 0, 0. Here, x does not have complement, that's why we have written 1. Y bar and z bar, that's why here we have written 0, 0. Plus 0, 1, 1. Plus 0, 1, 0. Plus 0, 0, 0. Now find the designation of this one. There is a blind method to identify the designation. To remember that, first write down 8 times 0 and then write down 1. Or 4 times 0 or 4 times 1, depending upon how many variables we have. Here we have only 3 variables, that's why I am going to write 4 times 0, 4 times 1. 1, 2, 3, 4 times 0 and then 4 times 1. 1, 2, 3, 4 times 1. Next 2 times 0, 2 times 1. 2 times 0, 2 times 1. Next alternative 0, 1, 0, 1. 0, 1, 0, 1. If it is 3 variables. See the equation? All the parts contains only 3 variables. That's why only for 3 variables we are written. Then here, the first one represents M0, M1, M2, M3, M4, M5, M6 and the last one represents M7. This is the designation. Then for triple one, what is the designation? M7 plus 101, then that is M5 it represents. plus double 1 0. See double 1 0. Where is double 1 0? That is M6 plus 1 double 0. That is M4. It represents 0 double 1. 0 double 1. M3 it represents 0 1 0. 0 1 0. That is M2 plus finally triple 0 that represents M0. Now after this, write down everything in ascending format. That is sigma of small m of, first here we have 0, then next 2, 3, 4, 5, 6, 7. See, 0 is present, next I have written 2, then 3, 4, 5, then 6, and then 7. Then the final canonical form of the given expression is sigma small m. Min term always represented in small letter m. If it is max term, then capital M we used to represent. Then the final solution represents m sigma of m of 0, 2, 3, 4, 5, 6, 7. Next we will explain the same thing. How to find the canonical form of a given expression with one more example. In the same pattern, find out which is a missing term, then their alternative values, distribute the equation, then finally calculate it. Now the second expression, second problem, AB plus ABC bar. Consider this is the equation. Then first part, which is a variable missing, which little variable is missing? C is missing. Whereas here, it does not have any variable missing. Then, here write down A, B, C plus C bar plus A, B, C bar. Now, distribute this. A, B, C plus A, B, C bar plus A, B, C bar. Remove the duplicate. Here, whereas ABC, first I am to write ABC plus here ABC bar, ABC bar. 2 times here we have that, I can remove the duplicates. Therefore, ABC bar. Now, write down their corresponding binary values. ABC here we have, if the variable does not have complement, then 1, 1, 1. Plus here ABC bar, then 1, 1, 0. Write down their equivalent designation. Triple 1 represents M7. Double 1 0 represents M6. Therefore, the reduced expression is sigma small m of 6, 7. Sigma small m of 6, 7. Next, I am to explain with one more problem the same thing. How to find out the canonical form of an expression. Consider we have an expression y z plus x bar y. Consider this the equation here, y z plus x bar y. Whereas in the first part, see, x is missing, whereas here z is missing. Therefore, x plus x bar represents 1, yz plus x bar y, z plus z bar. Now distribute this, x, y, z plus x bar, y, z. First I am going to take this with the first part, then this I am going to with the second part. Plus x bar, y, z plus x bar, y, z bar. Now remove the duplication. Is there any variable is duplicated here? X bar, y, z. Here also x bar, y, z. These two are common. Therefore, you have to write only one time. X, y, z plus x bar, y, z plus x bar, y, z bar. Now, write down their equivalent binary values. 1, 1, 1. If the variable does not have complement, then it write 1. If the variable is complemented, then it write 0. Plus, here it is complemented, that's why 0, 1, 1. Plus here 0, 1, 0. That's equals to small m of triple 1 represents M7. 0 double 1 represents, see the equation there part, 0 double 1 represents M3. 1, 0, 1 represents M2. Therefore, the final canonical form is sigma small m of 2 comma 3 comma 7. 2 comma 3 comma 7. This is the canonical form of a given expression. Now we'll explain one more problem in the same pattern. Fourth problem, that is x, y plus z. Consider this the equation. Then how to find the canonical form? In first part z is missing, in second part x and y are missing. Therefore x, y, z plus z bar plus x and y are missing. X plus x bar, y plus y bar and then z. Now that is equals to x, y, z. Distribute the given equation plus x, y, z bar plus, first I am to distribute these two part, x, y. First I am to multiply x with y and once again with x with y bar. Next x bar with y, x bar with y bar. X, y plus x, y plus x, y bar. First x with y and then once again x with y bar plus x bar y plus x bar. See the equation, first x, y, then x, y bar. Next x bar y plus x bar y bar, then z. Now once again distribute that, x, y, z plus x, y, z bar. Multiply z with the remaining all the variables, x, y, z plus x, y bar, z plus x bar, y, z plus x bar, y bar, z. Now, remove the duplication. See the equation, x, y, z plus, only for z there is a bar. See the equation, whereas x, y, z, here also x, y, z, here also x, y, z, only one time I can write x, y, z plus x, y, z bar. Then see the remaining thing. The remaining thing here only for y is bar. We don't have any duplication. If I see here, only for x is bar, whereas here y and z is bar. Then x, y, z plus x, y, z bar plus x, y bar, z plus x bar, y, z plus x bar, y bar, z. Now write down their binary value, 1, 1, 1 plus 1, 1, 0 plus 1, 0, 1 plus 0, 1, 1 plus 0, 0, 1. Now write down the equivalent by designation, M7 plus 110 represents M6 plus 101 represents M5 plus 011 represents M3 plus 0001 represents M1. Therefore, the final canonical form is sigma small m of, write down in ascending order, 1 comma 3 comma 5 comma 6 comma 7. 1 comma 3 comma 5 comma 6 and 7. This is the canonical form of sum of product form. Next I am to explain the canonical form of product of sum format. Now, see the given expression heading is conversion of product of sum into canonical form. Consider the equation, a plus b plus c into a plus b bar plus c bar into a plus b bar. In each part, in each max term, which variable is missing? Whereas there, in each min term, which variable is missing, that we are checked. Whereas here, in each max term, which variable is missing, that you have to check. Whereas a plus a bar represents 1. Whereas a into a bar represents 0. Now that we will use here. Then to convert the given expression, we will do a plus b plus c A plus B bar plus C bar. Here C variable is missing. A plus B bar plus 0 we will write, because this 0 represents C into C bar I can take. Because here C is missing, I don't want to change the given expression. On the further sake, here we are written 0. Now that is equals to A plus B plus C. A plus B bar plus C bar. A plus B bar plus C into C bar. Here which variable is missing? That variable into variable complement you have to take. Whereas in mean term what we have done? Missing variable plus missing variable complement we have considered. Whereas here missing variable into here we are using missing variable into missing variable complement we have to consider. Then distribute the given equation. A plus B plus C. Now A plus B bar plus C bar. Now distribute this one. A plus B bar plus C. Once first I am going to take C. Then once again A plus B bar plus C bar. Now same pattern, remove the duplication. For all the variable we does not have any complement. That's why I can write A plus B plus C. Now only for B and C it is bar. See here this expression as well as this part both are same. I can remove the duplication. That's why A plus B bar plus C bar. The remaining thing will be A plus B bar plus C. Now write down their binary value. Whereas in mean term what we have done, if the variable is complement, does not have complement, then I write 1. If the variable is complemented, then I write 0 in mean term. Whereas in max it is reverse format. If the variable is represents x, if the variable is non-complement, then we write 1. If the variable is not complemented, then we have to write 0. If it is complemented, then we have to write 1. Therefore, here what is the expression? The variable is does not complemented, then you have to write 0 plus 0 plus 0. 0 plus 0 plus 0. Now here 0 plus complement. If the variable is complement, then you have to put 1 plus 1. Then next 0 plus 1 plus 0. Now it's clear. This is the binary format. Now how to find their designation? The first one 3 times 0 if you have, then small capital letter M of 0 it represents. M of 0 first one. Then next one 0 double 1 0 double 1 represents capital M3. Next 0 1 0 represents capital M2. Therefore here to represent the final canonical form, pi of capital M of 0, 2, 3. Whereas in min term we used to write sigma of. Whereas in max term pi of we used to write. Pi of, that is 0, 2, 3. This is the final expression. Here you have to write in capital letter, whereas in the previous case we are written in small letter. For min term small letter, for max term capital letter. Now we are going to explain with one more example. In the exam they will going to ask both min term as well as max term. Then depending upon the question you have to find out whether it is a min term or max term problem. If it is min term, variable, missing variable plus missing variable complement we will take. If it is max term, missing variable into missing variable complement we will take. Now we will explain with one more example. X plus y, y plus z, x plus z, x plus z. Consider this the equation. Now here see, z is missing, here x is missing and here y is missing. That's why what we will do, x plus y plus z into z bar. For the second part, x into x bar plus y plus z. Now here x plus y into y bar plus z. Now distribute the given equation, x plus y plus z. Once again x plus y plus z bar. Next here x plus y plus z. Next x bar plus y plus z. Here also same pattern, distribute the given equation, x plus y plus z. Next, x plus y bar plus z. Remove the duplication. Here also x, y, z. Here also we have x, y, z. Only one time we can write. Therefore, the reduced expression is x plus y plus z. Next, only for z. For this one also x, y, z. 3 times we have x plus y plus z. Here also x plus y plus z. Here also we have x plus y plus z. Only one time we are written. Next, only for z there is any bar? No, only one time we have. Therefore, x plus y plus z bar. Only for x here we have bar. X bar plus y plus z. Here only for y we have bar. Then x plus y bar plus z. Now write on the equivalent binary value. If it is non-complemented, then we have to write 0. 0 plus 0 plus 0 here. But here, on the place of plus, you have to write dot here. Dot. Then here, 0 plus 1 into 1 plus 0 plus 0. See the equation? Wherever it is complemented, there you have to write 1. Wherever it is non-complemented, there you have to write 0. Then here 0 plus 1 plus 0. Write down their equivalent designation m naught. Next we have m1, capital letter m1. Next here 100 represents m4, m0, m1, m4. Next m2. Therefore, final form is pi of capital M of 0, 1, 2, 4. This is the final reduced expression. It means that on this class you come to know how to find the canonical form of a given expression, or you can say min term. Up to here if you find out, then we say it as min term. Then there up to here if you find out, then I can say that it is a canonical form. Next class we will continue with the remaining things. Thank you all of you.